is the same as before, so this is like actually like was this before, right? N, not number. But there is one extra thing. So that but then we have curly as we see before, and then we don't have the in that we had before, and then we had the same body of the function which was returned 2 times n. Okay, so basically this is define the same function. And if I go ahead and run it as before, so say print double 10, well, it should just do what we expect, which is double 10 and prints 20 for us. Very well. Now, there's a little funky little underscore here that we hadn't seen before. And what is that? Oh, I can take it out and probably it would be okay. Let's see. Yeah. What this does though is saying when you do call the function is optional whether or not you give the label for that variable. Meaning, when I do this, that n is the name that we're giving to this variable, right? Input variable. When you call it, you actually need to give the name for the variable that you giving a value to. So you call like this double, and then double needs a variable input variable called n. Then you say n colon, and then you give it the value that you want to call it with. So this should work. If I just call this, it's happy with that. But when you do put that underscore there, then you don't need to name the variable. Just go ahead and give it the value. Kind of figures that, okay, that's the first argument. So whatever they give, I assume that's for n. It's just a convention, or just a convenience in this case, to not give the value, the name for that input variable or parameter or argument. Okay, but in this case, because it's only one input that it takes, it actually happy even if you didn't say it's optional. It's happy when you don't give it a name, as we saw before. This runs fine. Okay, interesting. But the reason that's happening is useful to actually give a variable's name, the input variable's name, you see just now. If I go ahead and show you another function, how is this function different? Okay, interesting. So this function, I give it a name, kind of descriptive, double then add. But what's happening here is that the input parameters seems like there is 2 than 1. That is right, because functions, just like the juicer, which can have different produce inputted, can have more than 1 inputs. So in this case, I have a input variable called number, which is of type integer, and then comma, and then I have a second input variable which I'm giving a name add, which is also an integer. I'm designating both labels, variable names is optional, so you have this underscore there, and then the output is integer. So what does this function do? It just does what it says. It's double the variable that's called number, and then adds the variable that's called add. So let me just run this. What do you think double then add, if I call this function with 2 and 10, would do? Well, that's kind of simple, right? Number becomes 2 because this is the first argument, right? 2 kind of corresponds to the first argument, which is number. So basically, it's just like assuming number is 2 and assuming add is 10. So what happens when I print this value? So it becomes 2 times 2 plus 10. So that's 14, right? So if I just call this if I define this function and go ahead and call it like this, I should get 14. Sure enough, I get it. Okay, so what's happened is it assumed the order. So because this argument value was the first, it assumed it was for the variable that's called number, and the second was 10, which was the second one. So I assumed That one is for the add variable. And then it did the computation, returned the value for me, which was 14, and then printed it, right? Now, as you see, because functions take more than one variable, can take many, it actually becomes kind of confusing. Let's say if we had 4 things that it ran, you forget, okay, which one was the third one, what is it? And that's why sometimes and often it's useful to not make the names optional. So when you do call it, you actually need to name the variable so you remember what it is for. So you're saying number is 2 and add is 4. Does it make sense? So when you call it, because the underscore are not there, you're saying it's required that the label for each argument when it's called to be written like this. So you say double then add number 2 to add the variable being 10. Okay, so if you define the function like this, then you have to call it giving the labels. Does it make sense? You could see this is useful to give names, because otherwise, let's say if somebody else is reading your code, or maybe later on staring at your own code that you wrote a month ago, then it's not descriptive if you have just a bunch of values without any name. Always use names that kind of remind you, help you understand the code better. In this case, 2 variables. Okay, that makes sense? Very well. Now let's get to more interesting parts. And the interesting thing that's here is, what do you think is interesting about this function? Well, it's interesting. It has a name quadruple. Okay, it kind of gives away what it does. But what it's showing is that functions can actually call functions themselves. So because we have already defined the function double, if you want to do a quadruple function, you can just call the double function twice. And that's what's happening. So what do you think saying print quadruple 10 does? That's right, it should produce the value 40. Now, how is that possible? How does that happen? Well, let's go through it. There's something important that you need to learn when you learn about programming languages, and that is how the expressions are evaluated, what's called evaluated. And that's kind of like when you punch in some numbers in a calculator, the calculator does some computation and then shows you the final result. So that process of doing the computation within the interpreted languages here would be doing the computations and calculations and the processes that finally lead to giving you the final outcome, which is in this case printing the value 40 for you. So what happens when I say print quadruple? So I'll just go over with you the order of the things that happen. So the interpreter, which is what we're using here, says, okay, you tell me to print something. Okay, let me print something. And print itself, now that we are familiar with functions, is a function. That's why you see print, which is the name, and then inside the parentheses, it has you're giving an argument. So you're giving an argument, which is the whole expression, quadruple, and calling the function quadruple on 10. So itself is a big expression. So what happens that a function cannot be evaluated until its argument are evaluated. So it says, you tell me to print something, but I don't know that value of this whole expression quadruple 10 is. So what basically happens is kind of starts off a subtask and saying, okay, I need to evaluate this expression quadruple 10. Now it says, okay, quadruple. What is quadruple? It's going to say, oh, that's a function that you defined before. I know what that is. It's going to look at the type and says, oh, you're going to call it with the value 10. Now, is 10 needs to be further evaluated? Well, no, because 10 is just a number. It's what is called a primitive value, and the evaluation of itself is just itself. So 10 just evaluates to 10. It doesn't need to do further computations to get the result. So it's okay, quadruple is ready to be called because its argument is known to be 10, and it actually matches. It's a type of integer. 10 is integer, and quadruple has said I want an integer and one input, which is integer, as my input. And so goes ahead and says, okay, you're ready to call this function. So it's just going to go inside here, and what's going to happen is that because we've called quadruple on 10, it's going to assume n is 10 when we're inside this function, right? So it says, okay, now I need to say, because the quadruple says return this value. Now, because n is, so we're not there yet, right? So now it needs to evaluate this expression. So it says, okay, I need to evaluate this expression. Double is a function. What's this argument? Oh, its argument is another expression. I'm not ready to run it because I don't know the value for it. So what's happened is it's going to say, okay, I need to evaluate the value for this argument before I can run double. But that argument itself is another function called double n. So it's kind of like domino effect, giving the interpreter more and more jobs to do, because there are kind of intermediary steps that it needs to evaluate until it gets to the final result. So it says, okay, now I need to evaluate double n. What is double n? Well, n is not a primitive value, but it's easy because within this context, it knows that n is 10, right? So it says, okay, so that means double n is really double 10. And now I'm ready to call double function because its argument is a primitive value, 10. Now, what is double 10? It's going to look up double and says, okay, where was double? I don't remember what double was. It's going to go up and says, okay, here is where you define double for me. So it says, okay, let's run double. And the input for double in this case is 10. So if double is this, and the input, let's say the variable we've given is number, because we're calling it on 10, it says, okay, in this context, number variable is going to be 10. And then what I have to do is evaluate this, because that's what's returned. So it says, okay, that's really 2 times 10, and that is really 20. So it's going to be done with that calculation and says, okay, I just finished calculating double n, which happens to be giving me 20, right? So it says, okay, now I just evaluated that argument for that outer double call. So really what this is going to be simplified to double 20. And now we have another function call. So we repeat the process, this time number being 20, and doing again 2 times number as you visit that function double. And so we get 2 times 20 and we get 40. And so this one now gets simplified to 40. And what happens is now this whole expression, double calling on double of n, is going to be simplified to 40. Therefore, the print of this expression is going to be simplified to print of 40. And finally, print is ready to be called because its argument is a primitive value. And it says, okay, I know how to print 40. So it just prints 40 on the screen. So all these steps had to happen in order to evaluate this function call and print it quadruple of 10. Now that might be kind of confusing. There was a lot of steps. But the important thing to try to remember, and this might take some time for it to be crisply clear for you, is the order of evaluation for a program is important. So remember that the function cannot be called until its arguments are known and evaluated into simple values, primitive values. So this double wasn't ready to be called because its argument was itself a big expression. So then the interpreter said, okay, I need to evaluate that first. So he went and evaluated that. once you got the result from that, it says, okay, now I'm ready to be calling this outer function call. Okay? Alright, we're almost getting there for today. Now, switch gears a little bit. I'm going to show you a new expression. And what do you think this expression is doing? It has a little new symbol, which is this equal thing. So it's double equal. So if I go ahead and run this expression, I get true. Oh, you can now guess what this does. This equal is equivalent of a mathematical equal check. So it checks that the left and the right side evaluate to the same value. So the left side evaluates to 3 and the right side evaluates to 3. So they are equal. It says true. And now we have seen a new value, which is called a Boolean variable. A Boolean variable is just true or false. It's logical true or false. So remember, and the equal, two equals together is checking the equality of the left and right. Okay, so now we're seeing a new type, which is called bool, which is short for Boolean. A Boolean variable, as we've seen, can only be two things, only true or false. So because this is a value, as we evaluated before, it evaluates to true, it can be assigned to a variable, but because its type is Boolean, it cannot be integer or string, it has to be type bool. So that's why this variable that I'm calling AB has been given a type bool and is being assigned a value of what? That's right, this expression evaluated to true. So AB, if I define this, is going to have the value true. Okay, just some logic that comes in very handy in programming. Now, what happens if I run this? Well, we've defined quadruple before. Quadruple of 5 returns what? Quadruple of 5 should return 20, and then 20 equals 40 should return. That's right, it's not true, it's false. Okay, it becomes simplified to this because quadruple of 5 is 20, and then 20 is not equal to 40, so it says false. Now, a little bit about logical operators. We can have combined logical Boolean expressions by the operator which is double pipe, which stands for OR, logical OR. So the logical value for saying true or false is, if you remember your logic, saying true or anything is still true, so it's true. On the other hand, remember this, which evaluated to false. Okay, when we define quadruple, we said it doesn't take any name, so I think that's why you're getting an error here. Okay, so that's false, but this one is true. Now there is another logical operator which is 2 ampersands together like this, and that signifies logical AND. So AND is true only when both left and right side are true. So if I say print this part, which is in fact true, and the right side, which is false, it becomes true and false. So printing true and false should return, that's right, false, because false and anything is false.